Hello everyone, my name is Kirill. Today we'll take a look at working directly with FastAPI, and we'll also identify the differences between FastAPI and the more familiar Django or Flask, because there are actually significant differences in their approaches. We'll start with a bit of theory, just a brief overview. In fact, there's a separate video on the channel dedicated to building REST architecture. A hint will pop up at the top right now. As for the differences between FastAPI and, let's say, Django as an example, the difference lies in the approach. Django uses the WSGI approach, while FastAPI uses the ASGI approach. Well, the full forms don't really matter here. The point is that in Django, Flask, and say Cherry Pie or something like that, we have a synchronous approach, where our requests are handled synchronously. In FastAPI, there's an asynchronous approach, where we work asynchronously. Now, let's take a look at how this appears on a diagram. Let's say we have some kind of web server here, let's call it a web server, and then we have our ASGI, WSGI, and then our actual application. So AP, let's say a request comes in here. How does this all look for us? We have a request coming in. The request goes to our web server. This could be Apache Nginx or whatever else, it doesn't matter. Next, it goes to the ASGI or WSGI layer. And this ASGI or WSGI is exactly what helps our Python application interact with our web server. It acts as a kind of middleware that allows us to connect these two components. If with WSGI this happens synchronously, then with ASGI it happens asynchronously. WSGI stands for Web Server Gateway Interface, and ASGI stands for Asynchronous Server Gateway Interface. So basically it's the same thing, but in this case it's in the asynchronous approach. How does this actually work in general? When, for example, we receive a request, let's call it request 1, we perform some tasks here. Let's say we have task 1. All right, next we have another task. Okay. Next, for example, let's say we have task 2, and then we receive another request. So this is the second request. In the first task, for example, we might have some interaction with the database. When we work in a synchronous approach, we perform each of our tasks, well, sequentially. We receive the first request and we go to our task 1. Here we might retrieve something from the database, maybe do some calculations. So as you can see, basically this operation is quite resource intensive and takes a lot of time. And only after that do we move on to task 2, everything there finishes, and only then does the second request begin. If we talk about the asynchronous approach, in the asynchronous approach, when we handle a request, our request goes to task 1. This interaction with the database is an asynchronous operation. So at this moment we can switch to our second request. We switch to the second request, and here, for example, we process task 1 and task 2. As soon as the result is ready here, that is, as soon as we receive all the data from our database, then the second task proceeds. So during idle time, when we are basically just waiting for some data, just waiting for the database to return something, we can take care of some side tasks instead of just sitting and waiting for everything to be processed. This is the difference between the ASGI and WSGI approaches. We do things asynchronously. But the curious might ask, how does ASGI actually work? When we make a request, do all our requests really get processed one after another? That is, we processed one request, then the second request was processed, and so on. No, in reality, that's not what happens, because if we're talking about ASGI and WSGI approaches, we have a pool of workers, in other words. We have a worker pool. Let's say, for example, we have these little blocks here. Okay. Let's write it here. So let's write here B. All right. And so let's say like this. So when a request comes in, let's say this is the ASGI approach, right? The ASGI approach. When a request comes in, it goes to the web server. Then one of these workers intercepts the request and delivers it to our application. The point is that everything happens synchronously, but with workers. So if a worker becomes available, it picks up another task, another request, and starts processing it. It's the same in the ASGI approach. And basically, when we interact with Django or anything else, in the standard implementation, well, for example, when we use Ubicorn, we can specify the number of workers. The number of workers is limited. It is limited accordingly by the actual number of worker processes you have available. You can calculate this, but it's not really that important. In general, the standard 4 to 6 workers is usually enough. And if that's not enough, then it's better to switch to ASGI. Fortunately, for example, with Django, there are already some ASGI middleware layers that allow you to work with it. Yes, Daphne might not be the best or the smartest solution, but at the very least, it will work decently. Now, let's see how this works in practice. Let's create our FastAPI application. Where do we start? I've already created the main py file here. Basically, to interact directly with FastAPI, you need to install UVcorn using pip install UVcorn. Now, let me open either's our UVcorn. You need to install it, and you'll also need to work with SQL Alchemy. Basically, I've installed these two dependencies. So now we'll start building our application. Let's start by importing UVcorn, which is a lightweight ASGI server commonly used to run FastAPI applications. So basically, we are bringing in UVcorn here. After that, so if we are running our file, we take UVcorn, write run, and specify that our app is main app. Then we set the host. This is all standard. It will be 4 zeros. 1, 2, 3. Next, the port is 8080. Next comes reload, then comes the number of workers. All right, before we start building our application, we need to bring in FastAPI, which is a modern web framework for building APIs with Python. To do this, we'll use the import statement from Fastapi import FastAPI. This line of code allows us to access all the features and tools provided by FastAPI in our project. Let's create our application. Next, to interact with the database, we need to set up our database configuration. We create a separate file called database, py, and here we write so we import our SQL Alchemy. To begin, you need to import the create engine function from the SQL Alchemy library, which is essential for establishing a connection to your database. Next, import the declarative base function from SQLAlchemy, xtDeclarative. This function is used to create a base class for your ORM models, allowing you to define your database tables as Python classes. Next, we import the session maker class from SQLAlchemy. ORM. This class helps us create sessions which are needed to interact with our database using SQLAlchemy. After importing session maker, we set up the configuration for our database connection, making sure our application knows how to connect. As part of the setup, we define a constant in our code, and this constant will store the database URL, which tells SQLAlchemy where to find and how to connect to the database. Here, we'll specifically specify that we're going to use SQLite as our database. The file will be named SQLappDB as your database file. All right, now we create our engine. We write create engine. Next, we specify our SQLAlchemy URL for the engine. In this step, we configure the setting called check same thread within our configuration file, ensuring that this particular option is properly set as required. Next, we will now define the session local object. We specify the session marker. So after commit will be set to false so that we handle commits ourselves, and after flush will also be set to false so we manage all of that manually as well. And we bind our engine for database handling. So the engine, and we type out base equals the declarative base in our Python code, just like this. All right. So let's write a function to get, or rather to connect to our database using the getDB function. This function will be a generator function. It's worth mentioning that when we expect a dependency in FastAPI, we expect a generator function that will yield our values sequentially. But in the case of our getDB, it will yield just a single value, and that's it. That is our database, which we can now interact with. So getDB. Here we specify DB session local, and we need to use try because errors might occur. If an error happens, we will close our connection accordingly, handling it in the finally block. So basically, just like with a context manager, when we're done, when we've finished interacting with our database, we will always close it by default so that we don't run into any issues or even possible collisions. That's why we'll do it this way. All right, we've set up our database configuration. Next, we need to go back to the main py file to set up the creation of our database. How do we do that? We go to from database import session, local, then engine and bases. All right, good. Now we write base metadata create all, and we specify that we'll create all of this using our engine. So using our engine in this format, so what's happening here, we're creating the database. Here we specify our database configuration, create the engine for how the database will be created, and then create a session with our database. That is how we will interact in our current session, maybe set some parameters like auto commit if needed, and so on. And we import all of this into our main py file, and here we directly create our database when we start interacting with it. All right, basically this is more or less clear. Next, we will start setting up interaction directly with our application. We'll create a small CRUD application, we'll create a user, and in our models file, we'll write user py. It will all be very simple. This will just be a basic CRUD application. All right, now we import SQL Alchemy here. SQL Alchemy import. We need to import the Boolean type. Next, we need to import column and integer, which are necessary to define our columns in the table. And also string, we need to do that as well, just to make sure everything is set up correctly. From the database, we import our base directly, and then we define the user class right here in this file. It will be a subclass of base. Here we specify the table name. That is what our table will be called. The table name is users. Next, we define our columns. Our ID will, in this case, be column integer, then primary key. Index set to true successfully. It's all very simple. There will be two columns. We will also have a name column, which we will also define as a column. We'll specify that it will be a string. We'll specify that our name will be unique, just unique. True. And the index will also be set to true. All right, good. Now we've created our table, and now we need to create a DTO. Why do we need a DTO? Basically, we can't interact directly between the layers of our application, like between the service and the controller. There we must clearly indicate that our user table is coming to us. Basically, our user, our models, our tables, they should be hidden. No one else should know about them. Only our service should be aware of them, and that's it. A DTO is a data transfer object, which allows us to explicitly specify what we're expecting. For example, when we make a post request or when we update something. So it's actually a pretty convenient thing. And in this way, we avoid tying ourselves to our model and ensure that only our service knows about our model. Let's write the DTO. In the DTO, we do the same thing, user. Pyend here, everything is very simple. We'll use Pydantic. You'll also need to install Pydantic. And here we'll define types using base model, for example, the user class. This will be our base model. And basically here we'll only have the name field, which is what we expect. All right. Now, ideally, we need to write our service for interacting with our user. We'll do everything using the same approach. Let's write the service. Services, because there might be more of them in the future. Here we'll write user py. Now, let's set up our interactions. First, we need to import our user models. From user, import user. Next, from SQL Alchemy, we import our SQL Alchemy ORM session. First, we import the session, which is essential for managing user interactions. Then, from the data transfer object, commonly referred to as DTO, we proceed to import our user into the system. All right, that looks good. Now we'll handle the actual creation of our user. To create our user, let's define our function. We will expect data here. This data will correspond to the user, yes, to the user. In other words, we will expect a value for the user from our DTO, and we will also expect our database session. So we write user equals user username data name, which means we are creating a new user object and assigning it the username from our data. Next, we save all of this to the database using our DB. Specifically, when we call DB add user, we are adding our newly created user to the database, making sure that the user information is stored and can be accessed later. Next, we committing these changes to the database. And now we refresh our database so that our changes are already applied. So user, and in case of an error, we need to handle it somehow. Exception as E. Let's write, for example, our error, just print it out. That's basically all we need. And we return our user. All right, good. So here we don't need it. Next, we need to get our user, and basically we'll do it the same way, get user. Let's write the service. We'll retrieve by ID, which will be an int, and we also need our database. And here it's very simple. We just return db query, and we'll specify where we're getting all this from. We'll be getting it from our user table, and we'll apply a filter. So user ID equals ID, and we'll get our first record first. All right, next we need to update all of this update. Following the same principle as with creation, only this time we'll be updating our name field directly. We'll retrieve our user and then update them. Data, user weight, not user, we need user DB. And here we'll specify the session. Ideally, we should also specify the session here. Next, we need the ID of our record. And now we're going to update everything. First, we need to retrieve our user. dbQuery. So query user I. The filter works on the same principle. User ID equals the ID. We get our first record. And then for our user, we take the name and change it to the one we have in the data. Oh, and then we save it here. That is db commit. We commit our changes. dme. So first of all, we need db and of course the user. Then we use db to refresh our user so that they're added to our database, and we return our new user. All right, good. And finally, we need to delete our user. We do a remove. We use our session, take our ID, and get our user. Well, first, of course, we need to get our user. User db query user. We apply a filter. User ID equals ID. And we perform a delete. db commit. And we return our user, who in principle no longer exists. All right. So basically, we've finished the service. The only thing left to do is the controllers. We're going to create the controllers now in our separate routers folder. Let's create it routers. Here we follow exactly the same principle. User py. Let's go in. First, we need to import API router and depends. These are our two dependencies, which we'll use to interact with our router and with our dependencies, the dependencies that will be imported. And then we import our session, import session. Next, from the database, we import our get db function. First, we need to import the getDB function, which will allow us to access our database session throughout the application. Next, from the services module, we import our user service by bringing in the user object. This user service will help us manage user-related operations in our project. We rename it, making an alias, user service. And from DTO, we'll also get our user and rename it. Let's write our alias. Import user as user DTO. Good. Basically, that's almost everything. All that's left is to define our routes directly. We write the router, we write the API router. This is already an instance of our router. And in the decorators, basically just like in Flask, we'll define our routes. Router post, the request will go to our URL. Next, we'll specify tags so that in the docs section, we'll already have nice and well organized documentation in this case. So user, and we write our function as async, specifically asynchronous, since everything works in asynchronous format for us. Create. We will wait for our data and we'll expect it from user DTO. User. Initially they will be nan. And now we specify the interaction with the database. This will be a session as a dependency depends, which waits for our generator function. So the generator function, and that's basically it. Now, all we have left to do is to call our service, specifically the user service, create user passing in the data and DB. The creation part is basically done. Next, we write the route to get a single user router, get. Here, we specify our parameter in these brackets. We also set our tag so that everything is nicely organized in the documentation. User. And again, we write our asynchronous function get, where we receive our ID. It can basically be a string. It doesn't really matter. We'll use a string since it comes from the URL. Next, the database session. This is provided by depends getDB, which ensures we have access to the database. The same thing. And here we return the result from our service user, service get user. We specify the ID here and also pass in the DB. Actually, let's just call it id from now on. All right. Next, we write the route for updating our user router path request, which is used to modify existing user information. Again, we'll do all of this by specifying the user's unique ID here, ensuring we update the correct record. The fields involved are ID, tags, and user, each of which helps identify and describe the user in our system. We define our function, async def update, and receive our ID. And from now on, he will remain nan. Next, DB session will be depends get DB. We get our instance of the database. So, and here we perform the update. Basically, it's the same. We use the user service we wrote, pass update here, our data, the DB, and the ID. Actually, we haven't received the data yet. We need to accept the data here as well. Data equals user not equals, but it will be of type user. But initially, the parameter will be none. And finally, now deletion. The router handles delete. Here we specify our ID and set our tag to user. Async def delete. We receive our ID as an int and again create an instance of our database. We'll just copy it. So, and now we simply delete return user service remove DB ID. All right. Basically, we've already done everything. All that's left is to add our router directly to our config file. How can we do that? app include router, we write from routers import user as user router. This Python statement imports the user module from the router's package and assigns it the alias user router for use in our code. So here we specify our user router and set our prefix user. All right, basically that's it. Now we're going to launch our application. Let's start our server. It started up on port 8080. We go over and see that everything is started up. Next, we go to the docs and create our user, let's say Alex2. Since Alex1 has already been created, there we go. Now we have Alex2. Let's retrieve this user by the second ID. We can see that we've retrieved this user. Next, we'll do an update. We enter 2, and here we'll write David. We execute it, and we can see that everything has changed. And finally, we need to do a delete. By the way, in the delete, we didn't specify the tags. Oh, we did specify the tags. We just need to indicate the user here so that it's grouped where it should be. All right. Now we enter our ID as 2, and we can see that everything has been deleted. If we try to retrieve this user, well, then he will no longer be there. We see cache. That's it. Basically, this is how you can build your Craft application using FastAPI. We see that with FastAPI, we interact using the IGI approach. This is a synchronous approach, and it's much faster than the asynchronous approach. And in some cases, it's much cooler and outperforms in terms of performance. Now, there are already implementations of this approach for, say, Django and Flask in the form of Daphne and similar solutions. But the coolest option right now is to use FastAPI in some kind of microservices. That's basically it. The code will be in the description so you can check it out and see how it all works. Be sure to subscribe to my GitHub, give it a star, and also like this video, subscribe, and of course tell your friends about it, because I put a lot of effort into this. That's all for now. Thank you all. Goodbye.